Thanks for coming to this session. The title is Demystifying of OpenStack Deployments, OSP Cloud with Dell EMC. Let me say a few things about the background of this talk. My name is Sumedh Sathe. Randy Perryman is the architect of our solution, Dell EMC's Red Hat OpenStack Platform solution. He couldn't be here today. I'm giving this talk on his behalf. His daughter is getting married this week, so all good reasons there. But we put the talk together, and I hope that I can do justice to all the expertise that Randy has put into creation of this platform. I also have my colleague Arkady Kanevsky, Director of Engineering, in the audience here. We'll be both more than happy to take questions after the talk is over. What we are going to do today is we are going to walk you through the overall approach that we have taken when we created the Red Hat OpenStack Platform solution, validated solution within Dell EMC. And then at the end of the talk, we'll show you about a 5-minute video of that end-to-end deploy. The deploy itself takes about 2 hours. We have condensed out the main steps, about 5 minutes long, so that you'll get a whole idea of the whole picture, end-to-end, what to expect when you start deploying, what you need to configure, and then how do you debug some of the elements of the deploy itself. A little bit about our organization. Within Dell EMC, we belong to the Service Provider Solutions organization. About 2 years ago, Dell EMC made a rather large investment into the service provider vertical. All told, it's several $100 million. We have been taking components from all across Dell EMC. Servers is what we are known for, EMC being a part of the new company. Storage is what we bring to the table. We also have a pretty significant and open networking set of offerings, disaggregated networking. All of that is being brought together in this solution. And there are several other solutions of this nature being put together as part of the Service Provider Solutions organization. The most important thing to remember here is this is not just a lab experiment. This is a validated solution that we created together with Red Hat, and there is a whole support and services organization behind what we are going to talk about today. The nature of this work itself begins in the lab. Let me go right down to what happens in a lab when a deployment engineer or somebody who is trying to deploy OpenStack for the first time. What happens is we start on a journey, pretty much. You start opening the documents that Red Hat gives you. You start following the steps, step by steps. And one of the first things that happens is you have to figure out a lot of detail at the lowest level of hardware, the servers, the iDRAC, that is the management software, the networking of it, get all the connections right. After doing all of that, you take your first step, and then you quickly realize it's hard to see what's going on. So this is one of the most common sentiments that you hear when a deployment engineer starts deploying an OpenStack. The other problem, other side of the coin, is that maybe something is going on in the background, but how do I tell that something is going on? And then, right after that, is what's going on in the background when the deployment is going on. It's actually the right thing. How do I know? And if it's not the right thing, how do I stop it? So these are all very straightforward, logical questions that come up. And as a platform company, for us, the most common question that we get from our customers and partners is, what can you do to simplify this for me? As it so happened, for us, it was a pretty straightforward answer. Our own teams deploying our OpenStack platform solution in our own labs had these kinds of experiences. They gave us this feedback. We took that feedback and then codified these processes in what we call a straightforward tool, and we'll talk a little bit more about that tool. So the first step, or first requirement that we need to have when we are demystifying OpenStack installs is to be able to watch what is going on, that the install is progressing as you expect it to. That is the first step, being able to see what's going on. That means you need a single place where all this is going on and you can watch. watch it and see when it breaks, be able to observe that it breaks. That's the second step of demystifying. Then figure out what conditions led to the breaking point, what caused that breakage. It's usually one thing that happens in the networking area, for example. You got your VLANs set just so wrong, just one little thing that has a cascading effect over all other aspects of the deploy. And where do you start debugging? When a break happens, you need some clues and pointers as to where to start debugging so that you get it right on the next go itself. So simplifying all of this is what this talk is about. So starting from our labs, our own deployment engineers' experience, we created a tool called Jetpack. It's a deployment automation tool. It's open source. I'll show you the URL. It's off of GitHub. We welcome you to contribute to the development of that tool or take it for a spin. Give us feedback. The more feedback we get, we can make it better, and we want to give it back to the community so that it makes it easier for everybody. The simple idea here is to simplify the installation process, deployment process. It's not just a single step. It's probably 150 or 200 different steps. How do we minimize the number of steps and simplify them is the goal here. Identification of breakages. That itself can be challenging. Simplify that. And when there is the need to produce repeatable results, take action. Be able to take action. That's the other aspect of what Jetpack gives you. All this begins with a node in your OpenStack deployment called Solution Admin Host, or the SA node. That's how we refer to it internally. This becomes a key component in the story here. How do you demystify? The Solution Admin Host node has the components, the RHOSP director running as a VM within it, and a standard place where everything is logged. And then when you start observing those logs and start observing what's going on inside of your deploy, all of that on the Solution Admin Host, that becomes your single pane of glass, so to speak. Be it at command line today, that starts giving you the tools that you need to simplify your processes. So let's walk you through what Jetpack itself does. At a high level, it automates OOO. OOO, as everybody knows likely, is the OpenStack component that allows you to deploy OpenStack. It's OpenStack on OpenStack. That's what the OOO stands for. The great hope has been that OOO will simplify the whole OpenStack deployment process. So the community came up with the idea of taking OpenStack itself and applying that as an artifact to the main deploy, the overcloud deploy. So there is the notion of undercloud and overcloud. We took it one step further. Since the complexity of deployment begins with OOO configuration, we started automating OOO deployment, OOO-based deployments ourselves. So what Jetpack does is it takes the undercloud, RHOSP director, that's the name of the Red Hat product. It places it on a VM on the SA node, the Solution Admin Host node. And that's where it has essentially the control point of the entire overcloud as it gets deployed. Under the covers, it's using Ironic, which is another open source OpenStack component. Ironic is a name based on iron being the bare metal. If you don't know about Ironic, it tries to give you a single common layer so that all the hardware vendors can turn the knobs to make their hardware configured and ready for the deployment itself. We use that heavily under the covers as well. Then it manages the deployment of the overcloud nodes themselves. Obviously, there are three node types in the Red Hat OpenStack: controllers, compute, and RH/Ceph storage nodes. We have all of those handled and automatically deployed through this tool, through Jetpack. All of this is rather complex because just one level under the covers is where all the complexity resides. It's not many different layers. It's just one layer down. So what we observed was if we can aggregate that complexity and make that a simple to use capability and make a tool out of it, that will be very valuable. So we took a simple design thinking like approach. We said, let's take a two-pronged approach to reducing this complexity. Let's boil down all the detail that a deployment engineer needs into two config files. One is an ini file, the other one is a properties file. And I'll walk you through some of the elements of what each of the files contains, and you'll also see in the video when we edit the files for a regular deployment. And then that's it. Those two files contain all the information that you need for your deployment and drive all that deployment, the entire deployment using only those two files. We could, in the future, simplify all of this even further. In fact, as a matter of fact, our teams are devising more tools to do just that. We may combine these elements into one. We may extend them to include more features that the platform level optimization needs, but bring it to a point which is very, very straightforward for a deployment engineer. Get all the details in one place so that that gets your deployment successfully completed, hopefully in one shot. That's the goal. In our labs, as your labs, I'm pretty sure there is a whole notion of fat fingers. You wanted to type an I, you typed a 1, or vice versa. 0 becomes an O. Those two are, especially given the position on the keyboard, a lot of the times fat fingers. That happens. By just having that one ini file as a template to go to and minimize the changes or the information capture helps you tremendously. What's captured in the ini files? It's all the IDs that you need and the subscription info that you need to go to the Red Hat network and download the packages for the deployment itself. Several other configuration parameters, especially when it comes to features that get enabled under the covers. There are several NFV features that we have begun to enable. So those configuration parameters are also captured in these ini files. There are defaults, of course. If you don't want to muck around with those, you can certainly go with the defaults and you'll get a certain NFV profile as a default. You can go with that if you want. All the networks are described there. Profiles, there are two profiles that we enable. One is NFV for the telco customers. The other one is called XSP, and you'll see some of this also. XSP stands for all other service providers but telcos. So web services, for example, that's a great service provider like customers set for us. The other file that I mentioned, .properties, it's a JSON object that's getting described in this file. Essentially a per server piece of information. The IP address, the names, the interfaces, which interface is used for what purpose, the bonding pairs of those interfaces, all of that is captured in the properties files. So think of this as a known good starting point to begin customizing. So think of it, this tool as what it is giving you is you buy the hardware from us, you buy the networking from us, you rack and stack the whole thing, you set everything just so. You need a known good starting point and a place to go minimize the changes that you have to make and then launch a single deploy command. That's what these files essentially give you. This also starts becoming, I mean, we all have talked about infrastructure as code. You know, you want to be able to say that I want to deploy several hundred machines. Here are the descriptions of it. That becomes infrastructure as code. Think of this as deployment as code. That's the direction that we are going in. At the same time, one more thing that I want to mention is on the first day, if you remember, the keynote, the Red Hat guys showed an excellent example of where they want to take Red Hat OHSP Director. OSP 13, they showed the UI. They have begun to show the profiles. They have begun to show how different features are getting turned on. There still are a lot of moving parts under that nice presentation that they gave us, under the UI. A lot of that still has to be configured, some of it by hand, some of it through the UI. We still think Jetpack can work with the Red Hat OSP Director UI. In the lab, we have some work begun already in this regard. We will ride that curve along with Jetpack, along with Red Hat as they take OSP Director in the direction of more better UI-based methodologies. Under the covers, I think Jetpack will still play a role. So let's say you created these two files, you modified them, you adjusted everything that you needed just so, and now you need to watch the progress. So where do you go? You log into your SAN node, you start looking at a single location. What Jetpack does is it starts putting a log file in a single place, /auto_results file. It looks crude. I understand for now it's not a nice, sexy UI. All of that is true. But to a deployment engineer who did not have anything to go with, here is one place that they can start looking. it's time-stamped. You have a sense of history, what happened in the 5 installs below, what did we do, what changed this time. You can run sdiff side by side. Having a log file in and of itself, as simple as it sounds, that tail -f is helpful. Not quite available today with OpenStack installed. So we learned it in the lab. We need something like this, and we did it. It begins with the deployment process itself on the SAR node, and one of the first things that the deployment process does is deploys director. RHOSP director itself deploys it in a VM. That's also automated, by the way. You don't have to deploy it by hand. If you have done it in the lab by hand, that's one of the first things that you have to do. Stand up that VM, configure it, call it director, and then give it all the parameters that it needs to launch the overcloud. We do all of that under the covers in Jetpack for you. Once that VM is up and running, OSP director VM, you can start watching a particular folder called pilot for the director log itself. So up until that point, you are watching the undercloud getting deployed, and then the overcloud deployment begins. So we are giving you 2 points where you can go look, check for what's going on. How do I know something is happening? Is it happening? Is the right thing happening or not, or is it failing? Several things happen under the covers. As you can imagine, it's an automated tool. It needs to capture some information, save it for later, and some of that happens in files that it creates all along the way. Again, an arcane fact here, there is a file that gets created, nstack env.json, new stack environment. That's what it stands for. I mean, engineers, me being one, I name files, minimum number of characters. That's good enough for me to remember 6 months from now. That's what this is. But suffice it to say, this file gives you a hint that you are about to begin RAID and BIOS configuration. So until that point, the undercloud is collecting all the information from your platform, and it's starting to create artifacts that it will start using. So you watch the creation of this file with Jetpack, and that's when you know it has passed a major gate. It's about to start configuring your RAID and BIOS. Let me talk a little bit about that. A lot of the times when you listen to talks about how do you deploy OpenStack or read manuals and books, very few of those will go into the guts of what it takes to deploy at the hardware level, the configuration. Every little BIOS flag that you have to turn on. If you, SRIOV, for example, you have to turn on the NIC and the port in some NICs. All this detail sometimes is missing. And then you are left wondering, I deployed the whole thing, it works, why is SRIOV not running? You have to go all the way back and figure out that the BIOS flag is not turned on. We do all of this under the covers for you if in the ini file you said, I want to turn on SRIOV or OVSDPDK or such a thing. So all this happens under the covers and given as input to Ironic. You start looking for what are the artifacts being generated and how do they start appearing. When this process starts, the RAID and BIOS configuration starts, you can start doing simple Ironic node list. But you as a deployment engineer, you need a place to know or a point in time to know when do I start doing Ironic node list and which nodes have been configured, which ones are not. So this is in Jetpack, you start getting a place where, okay, it has come this far, now it's doing RAID BIOS, and then it will go on to do overcloud deployment as well. At this point, overcloud deployment has begun. And the best advice here that we can give you, and we use day to day, is start using OpenStack tools to watch the deployment. Several of these, I'm pretty sure you guys know all about. Use heat and all the capabilities that gives you. What's the stack list, resource list, given the stack name, the deployment list, event list, put an minus N5 on it, and then use the classic Unix. I mean, this is 40-year-old technology, but sometimes you just need to have a way of knowing what to look for and what kind of watch command along with heat resource list, pipe it to grep -v. If you don't want the nodes that are completed, only the incomplete nodes, you give the -v flag on grep, and -I will give you all caps complete, all small complete, or capitalized complete, capital C complete. All of this goes to show you, this is our experience. if you want to watch all these things in flight, start crafting some of these command sets, commandlets, using OpenStack tools. I think one of the common questions that will be asked is, hey, Dell EMC, you have automated everything else. Why not automate this watching? We'll get there. What you are seeing is a snapshot, a point in time. We are working on taking these processes to the next level, make the logs, the watches better. At the same time, make these processes play with the RHOSP Director UI that Red Hat is crafting. So expect progress in both those directions. And again, we welcome community's input since this is an open source tool as well. So continuing along these lines, heat resource list stack name, do the grep I or minus I or minus VI to see complete. And by just for looking for that string called complete, you get a sense of how far along has your progress come. And you are checking it every 5 seconds, basically. So when you do minus VI complete, you keep seeing what has not finished, the work that has not finished. And when the command execution completes, you are at the end of the deployment. If everything has succeeded, you will not have a match on that minus VI complete. Or a failure might turn up. If that happens, you'll start seeing, or you can grep for errors as well. But indication of success or failure comes when you keep watching that file and the nstack env JSON file and the heat resource list command here. Generally speaking, a failure is at the end of these log files. That's where you know how to read them. But in the future, we will take all this output and start automating it, enhance the amount of automation here. So what happens when a failure is spotted? Some of the hints or guidance that we would like to give you is use a mix of commands here. Heat is applying the deployment logic to all the resources that it has at its disposal. That begins with, does it have all the resources that it needs? So do a resource show. You want to see what the deployment status is. Use heat deployment show, heat event show. As NOVA nodes start coming online, do a NOVA list. Sometimes that server ID, there are elements of that deployment that fail. Huge page enablement failed, for example. The server was deployed, but huge page enablement failed. What happens then? You need to find out what server that was. You do a NOVA list, go to that server, log in as OSP admin, OSP_admin, the standard login, and look at the kernel logs. Some of these elements are deep down as KVM is logging these error messages on these nodes. But that's where you at least have a way to know where to look. And when NOVA elements fail, you log in and look for messages that pertain to those features being turned on. Likewise for Ceph, not terribly different, just showing you the NOVA example here. In our experience, 9 out of 10 times, it's the network. Generally speaking, if you get all your configuration right, if you connect everything up properly and double check it, it's not the nodes or the memory or the Ceph and RAID configurations, it's a network. So let's quickly go over the most common errors that we have seen in the lab and struggled with. And some of these are really outside of what Jetpack can do and can handle. It's almost always, the first thing that we check is VLANs, your VLAN and switch configuration to support those VLANs. If you mistype one VLAN number, VLAN ID, that leads to a problem, both inside the ini files and your switch config. We are, by the way, also on path to automate switch configuration. So think of that SA node as a single point that will work with 3 switches in our solution, 2 leaf switches in a single rack, and an out-of-band management switch. And from the ini files themselves, will generate the configuration automatically. When you do that, you are able to eliminate that part of dependency of errors as well. The second one, again, it comes back to fat fingers, but I have to say this, it does still happen. I mean, we are trying to minimize this. There is no way to validate a password. Password is what you set it to be. So, I mean, we can look for the rules, but there's no way to validate what the password that you set and what you're typing later on. That's actually the third point. Extraneous characters can also lead to the password being wrong. But the most important point of this slide is that look at the most common list here. By using jetpack, using those two configuration files, we have minimized the possibility of errors for you. And 2 out of those 3 errors are outside of what jetpack can handle today. So just by using jetpack and this methodical, structured approach, you're already minimizing your most common list. All right, so you deployed jetpack, you deployed your overcloud, your OpenStack using jetpack. What now? How do you know that everything worked? For that, jetpack has an extension called sanity tests. It's essentially a macro test suite, and it does a bunch of things for you. Create security groups, create projects, users, upload images, boots up an image, add IP addresses. Then floating network is created, given an IP address is given to the instance, SSH into a controller, then from the controller into the net through the net NS to that compute, and then ping that compute. And when you establish that the tenant network connection is established, that is when you know that most of OpenStack is operational. That compute is able to access the storage and the network. At that point, you are ready to get to a point where your VMs can be launched, your VNFs can be launched, and start making use of it. Most of the times, you may have tools to do this that are outside of your deployment environment. So there may be a gap between your deploy complete and a VNF vendor or your own VNFs coming in and start deploying. But to bridge that gap between the two points in time, you need something like the sanity test. Let's quickly look at more elements of the sanity test. These are all functional tests. They are not operational. We are not testing the cloud operations themselves. They're validating that deployed solution itself and cleans up after it completes. It doesn't leave any footprints, doesn't take any pictures. It's a trail, but trail that it's walking, no footprints, no pictures. And it can be invoked at any time. Let's say day 100, after your deployment is complete. You want to make a few changes. You need a tool like this to run a sanity test at that point. Has everything still been continuing to work or not? So you can essentially run it at any point in time. I know the type phase here is too small, but just wanted to leave you with what the output of the sanity test itself looks like. You launch the sanity test like so. Then in the middle there, you start seeing all the resources that it sees the sanity test element. The third piece here is it's beginning to execute flavor creation for your VMs to be eventually launched. That's that piece. And at the last is it's pinging that VM instance and establishing that the tenant network is completely connected. At that point, you have worked through the majority of the OpenStack elements, the API servers, the private API network. All of this is functional, up and running. Wouldn't you, as a deployment engineer, feel better handing off this OpenStack to your VNF users? Now they can come in, start deploying their projects, users, and start deploying VMs. You can tell them, to a certain extent, this is the deployment that works now. That's a good architectural boundary, if you will, between you and your users. Just a few ideas on how to debug some of these connectivity issues. Your controller nodes are your routers. They are virtual routers, but all your traffic is going through your controller nodes unless you have enabled DVR. We are about to enable DVR ourselves. Once we do, Jetpack will also provide support for DVR. But until then, your traffic may be going through your controller nodes, which are your network nodes as well. So treat them as your routers, physical routers. Make sure that intra-cluster connectivity with the controller nodes is established. A lot of the times, that's the problem. That's one of the problems that we see. How do you start debugging for these connectivity issues? Focus on the controller. Establish that the routes to the controller are functional. That means pinging the controller's IP address, external IP address, or routes out of the controller to make sure that the traffic is going to 8.8.8.8, for example. But focus on the controller to make sure all your traffic has no impedance between the two endpoints. Default routes, that's another place to look at. Many a times, your default route configuration, maybe you intended to do a /23, became /22, and that led to a failure. So look for those clues there. And this is all pretty standard, piecewise, methodical approach to network debugging. I don't want to sound like there is something new here, but it happens repeatedly. And it's good to know, good to have a checklist of, have we checked all the intra-cluster connectivity through our controllers or not? Okay, how are we doing on time? Okay. All right, at this point, end of the prepared slides themselves, I'm going to show you a video of the deployment, and we'll quickly walk through. So you'll start seeing all these elements in this video, what I talked about. This video was captured by Randy on one of his machines in the lab. I mean, Randy deploys probably twice a day. I mean, this is a pretty large stamp, as we call it, 10 servers minimum, 3 controllers for HA reasons, 3 computes, and 3 Ceph nodes. You can expand the number of compute nodes from 3 to 9 in a single rack, or you can add another rack of all computes, and the controllers and the storage will still support it. This rack has 2 leaf switches. Why 2? If one goes down, we want the other one to pick up the slack. So the design of this architecture is fully highly available. There is an out-of-band management switch as well. And the networking in this demo was all 10 gig, but we are also offering 100 gig and 25 gig in the server. So 100 gig switches and 25 gig in the server with 4-way breakout cables. So if you want more capacity going to your computes, you can also play with that. So here we go. Right. Maybe a little hard to see, but I'll stop at a couple of points here. So you start seeing at the beginning of time, when you start deploying, you have the SA node, you download Jetpack, copy Jetpack, and start editing out, creating your own ini files. Okay. So what you see Randy here doing is we provide a sample ini file for each of the profiles, the CSP profile and the XSP profile. CSP is the NFV profile. So he made a copy of the 2 profiles, the ini files for them, and renamed them to demo.ini. And likewise, he did the same thing with properties, and he's showing you what the properties file looks like. So let's take a pause here. As I said, this is a JSON formatted object that describes your hardware and all the details that go with it. This is the SA node, so is director, that's the VM, is dashboard, that's a Ceph dashboard, that's the other VM that runs. And then is controller, is Nova, is Ceph are all the other flags. And then for each node, you're capturing all the details for that node type. So you'll see Randy editing this file to get it just right. So you begin with a known good starting point, and you edit out only the pieces that you want to change in your lab setup. So he's changing the IDRAC IP, the management IP, and he essentially goes through all of these. And you can write scripts to automate these pieces as well, to generate the properties file, to minimize the number of errors as well. So controller is true. Having service tag there helps. So logging becomes helpful, because when you call Dell for any of the issues, the first question that you are going to get is, what's the service tag number? They are always going to want to know that is the machine in support or not. So get the ini file, correct profile, choose the profile, and then you'll start getting the feature set for that profile. In this case, for the CSP profile, we have enabled huge pages, NUMA, that is CPU pinning, and OVSD PDK. And other features are following these 3 in the near future. Those will come online as well. So now he's going to start editing the ini file. Don't know if you can see all the details, but there are stanzas. All the details are organized as stanzas. So let me take a pause here. So just by changing that one flag, profile equals XSP or CSP, you get out of the box all the settings for that profile. So XSP, you get the default cloud for web service-like applications. If you change that to CSP, you get the defaults turned on. The huge pages, 1 gigabyte, 96 pages by default, that matches well with the minimum amount of memory that's in our solution. the NICs that are going to be used by OVS DPDK, the CPU pinning profile. One of the issues that comes up with CPU pinning is the numbering of your siblings, threads. All of that is taken care of under the covers for you when you make that profile, set that profile to CSP. Let's go forward. He changed out to from CSP to XSP. He's editing demo.ini for some of the features. Right, changing out VLAN IDs. You know, your lab manager may have a requirement which VLAN IDs you can use or you cannot. Accordingly, you have to change out a lot of the features, and he's just rolling through fast here. But suffice it to say, one place to go look for all the changes or errors that may be. By the way, I don't know if you noticed, the subscription ID and the password is also captured in this file. And without that, you cannot deploy. Okay, this is where I'll back up a little, just a bit. Okay. So he edited the ini files, properties files, got everything just right. And look at that one command that he launched, /deployer.py with the ini file as the input. That is it. That's that one command that will deploy your entire overcloud, undercloud and overcloud. This is as simple as we wanted to make it. At this point, once you launch this command, all the activity is getting logged into that log file that will show in the demo as well. And you can watch it. You can start seeing how far along is it? Is it doing the right thing? Has it failed? If it has failed, then you can start taking actions. So what he's doing is he has opened up another terminal, went to that /auto-results file, deployer.log, timestamped, and then on the director, once it's installed, the other file. And he starts doing tail -f. That's the example of what goes inside that file. Now, all the actions, all the steps, the 150 steps that you have to normally take manually are taken by the script and being logged in this single object, single file here. All right. Checking the status of the deploy on the SAR node, you know, how far along has it come? Has it downloaded into the pilot directory all the pieces of the software that it needs? And that's what this screen just showed. Next up is, now that the director node has been created, and some of this is fast forward in the video, he's now going to start watching the director install part of it. And that's where you start seeing the elements of the overcloud as they start getting deployed. And there you have it. I mean, at this point, you are in charge. You have one place to look at all the details of what's going on in the platform. If it has come this far, your RAID and BIOS, all of that has worked. Your overcloud deployment has begun. Its storage console was being created. See the instack env JSON file. It's just got created. It's empty. And at that point, this is the undercloud that he's sourcing the stack RC for. And he starts getting the resource list for the undercloud. And at that point, you can start watching, has your RAID and BIOS configuration completed or not? You can watch it just by looking at ironic node list. And at the end of it, you have all the nodes in your stamp completely configured, and the actual overcloud deployment is about to begin. And we have fast forwarded this a little bit. Cloud demo is the name of the cloud that you're creating here. At this point, you can start watching heat resource list with the cloud name. Cloud demo is a cloud name. And some of the same commands that I showed you earlier on the slides, keep watching them as you go along. I think he has fast forwarded this element a little bit. There you go. You start seeing the list of nodes and the actions that are being taken starting to shrink. At that point, you know that things are progressing well. They are successful so far, and there you have it. I think at this point, stack deployment is complete. And so you start seeing overcloud deployment status create complete. So you know what to look for. You can start creating your own scripts, your own checkpoints if you want to know what to look for. You can train your employees, your lab mates, your engineers that work for you. The idea is to be productive as soon as possible with your OpenStack. Okay, you shouldn't be spending weeks and weeks trying to get the OpenStack to run, to deploy correctly. So at that point, you're done. I think Now we'll go into the sanity test part of it. There you have it, /./sanitytest.sh. And once you start, after the install, you enter the pilot directory, deployment folder under that, and launch the sanity test. There you go. And it's going to walk you through all the API calls that it makes to the overcloud and confirms project creation works, user creation works, networks creation works, external floating IP assignment works. At that point, if sanity tests all pass, you have a working OpenStack. You can even provide this report to your customers saying, this is all that has worked. Now you go take it for a spin. So there you have it, folks. It's a glimpse of what we have automated, what the problems that we faced in our own labs, and then we took the lesson from that and automated from that experience. Let me leave you with the link to our, all right. Okay. So here is a link to the project. As I said, github.com/dsp-jetpack. And then again, jetpack is capital J, capital P. Feel free to go to the website, the GitHub repo, download it, play with it. Let us know your experience. And by all means, contribute. We would love that. Okay? Hope this was helpful. I mean, it's something to be said for the engineer who struggled through these deployments for days and facing all frustration. When they see this, in a couple of hours, you start the deployment, go get your lunch and a coffee, come back and the deployment is done, or something has failed, you at least have a sense of where it is. It's like their faces lit up. I mean, they don't have to struggle through all the detail. This is how we are giving them a set of tools to go make it easy and then work through all the details there. So I hope this was helpful. As I said, go to the tool, download the tool, GitHub repo is there, and contribute. And thanks for coming. I appreciate it.